Hey everyone, my name is Joe and welcome to part 4 of the Godot top-down shooter tutorial. In this video we're going to be talking about how to spawn bullets, how to use signals and connect to them from the UI and from code, and how to destroy bullets that you've spawned after a certain amount of time. So as a recap of what we did in our last video, we had a player controller where we can move our character around and we could shoot by clicking. And it all works and feels good, except for the fact that bullets will actually move with our mouse, which is obviously not what we're going for. So the first thing I want to do today is fix that. I want to create a bullet manager that our bullets will be children of rather than the player, so that they won't be dependent on our mouse movement. So right now, if I come into our player, we're spawning all of our bullets from this script right here. We're spawning them as children of our player. And that's happening because of this line right here where we're creating our bullet instance and then adding as a child. So the first thing I want to do is get rid of this line. And you know, if we run it right now, bullets won't appear, but that's okay because we're going to fix that in just a second. So what we want to do is whenever the player attacks, we need to communicate something. We basically need to create an event to tell whoever cares that a bullet needs to get spawned. This is a pretty common paradigm in programming called event-driven programming, and the way we do it in Godot is through something called signals. So in order to declare a signal, you can just come up to the top of a file. So I'll do it up here. And what we're going to say is just signal, and then we'll say player fired bullet. So when you're declaring a signal, you are describing an action that has already taken place. So you usually want it to be in the past tense. And it's perfectly fine to have a signal like this right now where there's no parameters. We do want to have a parameter here though, because we're going to create our bullet and then we need to pass it alongside the signal with whatever we end up, whatever ends up taking care of it. So we can do that by saying, just similar to a function, we can just add a parameter in parentheses here. So we'll say bullets and do that. And now down here, so instead of adding the bullet as a child to our player now, I'm actually going to call emit signal, and you'll see it'll autocomplete. It'll detect that we added this new player fired bullet signal, and it'll be right there. And I'm also just, after you give it the name, it's you just add any parameters you want to pass in. So since we added a bullet parameter up here, I need to have that in here as well. So I'm going to say bullet instance. So we're going to emit this signal and we're going to pass along our bullet instance. So this is all well and good, but now we need something that will actually listen and handle this signal that we're sending up. And how we're going to do that is come over to our main scene over here, and I'm going to add a node 2D. And so it's a pretty common use case in Godot or in programming where you'll want something that is in the scene but not actually visible. You want it to either just contain data or have some functionality or do some things, every frame or whatever. You just want some functionality to happen, but maybe that doesn't like show up visibly on the screen, which is the case for our bullet manager. We want it to contain all of our bullets as children but not actually do anything itself visibly. And so node 2Ds are a great base. They're the base node for all 2D nodes, and so they serve that purpose really well of just something that you can use to have some logic to it without actually showing up. And so I'm going to call this bullet manager. Okay, there we go. And I'm going to add a script to this. So I'm going to do attach script, and we'll just call it bullet manager for now. Eventually I'm going to refactor and move around our folders just to organize it a bit better, but for now we'll just put things in the root directory. So we have our bullet manager, and before we get to that, we actually don't have a main script right now. So I'm going to add a main script too. I'll create that. And so basically what we need to do is at the beginning of the game, we need to get our player and we need to get our bullet manager, and we need to connect the bullet fired script or signal, from the player to a function on the bullet manager. And the way we're going to do that is in our main script, we're going to get references to both those things. So we'll say onReady var bullet manager, and we will call this bullet manager. We'll do the same for the player equals bullet manager. Okay, so now when basically our game starts up. When everything is ready, we will have references to our bullet manager and our player. And what we can do when both those are true, we do have those references. Let me get rid of some of this scaffolded stuff. We can say bullet manager dot, or whoops, sorry, player dot connect, and we'll see a list of all the signals on the player. It won't pick up the one we added since it's not typed, but we know it's there. So I can say player fired bullet, and then we need to say, we'll do bullet manager, and we'll say handle bullet spawned. Okay, so let me break down what this line is doing. Whenever you connect a signal, you call connect from the node that has the signal. So because our player fired bullet signal is on our player, we have to call player.connect. So we do that, and then the second parameter is you're passing in which object is going to have the function that will be called as a result of that connection. So our player has the signal, and our bullet manager has this function which we will create that should get called. So what's going to happen now is every time that the player clicks, this signal is going to get fired, and our main script is going to get it here. And because of this connection, it's going to get the bullet manager and call this function. But right now that function doesn't exist, so we need to implement that. So I'm going to copy and paste the name of this and come over to our bullet manager here. Going to get rid of this real quick. There's a way you can turn off all the like default comments and scaffolding and everything, and I've just been too lazy to do that. But so what I'm going to do is say func handle bullet spawned, and we'll say bullet. Okay, so now what we can do, since we're getting our bullet passed into our bullet manager, we can actually add that bullet as a child of the bullet manager. So I can say add child bullet. And now what's going to happen is that whenever we click, that signal is going to get fired, our main is going to send it over here, and then this handle bullet spawn function is going to get called, and we're actually going to add the bullet as a child of our bullet manager. And the thing that we're going for is because this bullet manager is not a child of the player, our bullets are not going to move relative to the player's rotation or transform or position, whatever. So before we test this, there's one other change that we're going to want to make. If I come back over to our bullet, or to our player, excuse me, in our script here, so you'll notice that previously we were trying to set the direction of our bullet before it's added to the scene tree, because now we're adding it after this signal gets emitted. So we're going to get some errors here if we try doing this. And what we really want to do is actually add the the position and the direction of our bullet as part of our signal. So we're basically saying, hey, we fire, like a bullet needs to be spawned going this way, starting at this position. And it kind of makes sense. One of the nice things that this will let us do is something we call separation of concerns. And what that is you want to make sure that your code is broken up into blocks or chunks that are just focused about the things they need to be. And if we look at our player, for example, our player doesn't need to know how bullets are spawned or like what information a bullet needs. A bullet or a player should really just be responsible for saying, hey, the player attacked, and we should let something else know the logic for how our bullet actually needs to get spawned. So not only is this going to make it a little bit cleaner for our player, it's also going to let us separate nicely the things that our player doesn't really need to know about and let our bullet manager handle those, because that's what it's there for. So what I'm going to do is just take out pretty much all of this code right here. I'm just going to Command X to cut it. And then what I'm going to do is come up to our signal and not only add a bullet, but also add a position and a direction. Okay, so now we have not just the bullet, but the position and the direction. So we actually need to add that down here when we're sending off the signal. And I'm realizing I actually got rid of some lines we needed. So we need to give it the position and the direction. So what we're going to give it is the position is end of gun dot position, because that's where we want it to spawn. Let me get rid of this one here. And then we need to give it a direction. So we still need this direction to mouse line we have here. So I'm going to do direction to mouse. And then because our bullet instance is not actually readied, it's not added to the scene yet, it's not added as a child of our manager, it's not actually going to have a position. So we're going to get an error if we try using this line here. So I need to change this to also be end of gun dot global position. And then I can get rid of this one because we're not doing that yet. And so now we're sending out our position and our direction as part of our signal, which is perfect. And the thing we need to do now is actually come to our bullet manager to where we're calling this function and come into here and actually add those parameters in too. So we'll need position and we'll need direction. And in just a sec, once we finish this, I'm going to come back through and we'll refactor this a bit to use static types here, which are a cool feature of GDScript, but we'll just get it working first. I did just notice too a bug in main. Oh no, okay, we're all good. Take that back. Anyway, so now that we have this, what we need to do is we can set our bullet's global position to be equal to position, and we can set our bullets. This is where we added that one. Let me go back in here and check. We added that set direction function, so we can say bullet.set direction. And so speaking of static typing, hypothetical question, wouldn't it be great if we had good auto completion for stuff like this? Like, we know that set direction is a function on our bullet, so wouldn't it be nice if I were to just say start typing set and it popped up? Well, you actually can get that in GDScript, and we'll do that in just a second here. So let me do set direction and we'll say direction. Okay. Oh, real quick, I'm noticing I needed to write bullet here to set the bullet's global position, not our manager. Okay, so let's try running that now. And if I shoot, you'll see it's still messed up, but it looks like it's going in the right direction. I think I know why this is happening. I bet if yeah, okay. So the reason that's happening is because I was accidentally setting our bullet to spawn at the end of gun's relative position rather than its global position. And so it was spawning, if I come down to our end of gun, it was spawning 31 units to the right and 10 degrees down of, right here, this is of the player. These are relative coordinates to the center of the player. But then when we set it as a child of our bullet manager, it was actually getting spawned, 31 degrees to the right and 10 degrees down of main. So it's always getting spawned in this corner, which is what we don't want. So all we need to do, set this to global, and we'll have fixed that bug. If I dare claim victory ahead of time. And sure enough, what do you know, but it works. Oh, this is sweet. Guys, this is so cool. This looks great. It feels great. Nice. Awesome. I think we're good with that. So now that we have the firing working correctly, I want to make sure that we have our bullets rotated the right way. It just, just so it looks better. And so if you go to our bullet, you'll notice that it's actually rotated a different way than our player. Our player is rotated facing right by default, which, like we talked about before, is kind of like the default, 0 degrees is kind of facing to the right. So we want our bullet to be similarly angled. So we can select our bullet, come over here to its rotation degrees and set that to be 90 and just save that. And then what we can do, so there's a couple different ways that you can get the direction, that you want something to fire in this case. Just an easy kind of, it's not maybe the best way, but a super easy and simple way to do it is create another position 2D. I'm going to call this gun direction. And what I'm going to do is set it just a couple units further out than our end of gun. So I'll do 34 in this case. And so what this is going to do is it means that no matter which direction our player is rotated, we're always going to have the same, we're always going to have the correct direction, like the angle, the vector between these two positions is always going to be correct because it'll rotate with our player. And so this is kind of like a quick and easy way to be able to calculate that angle at all times, is just by getting the direction between these two, getting the difference vector between both of these positions. So I'm going to create this gun direction thing here. I'll make a reference to it here. So onReady var gun direction equals gun direction. And so what I want to do down here is we're actually going to replace the previous things we were using that got our global mouse position, because one issue with that is that our player rotates at its center. And so the rotation, if we try to use the mouse rotation, is going to be lined up with from our center. And so our bullet is always going to be slightly angled differently because it's going to be trying to go to our mouse. And if our mouse is right here and our player is facing this direction, this is the angle we're going to get, which is what we don't want. So that's one reason why we have to make this separate direction calculation. So I'm going to get rid of what we're currently doing, and I'm going to change this. Let's say var direction, and this is going to be our gun direction dot global position minus our end of gun dot global position. So this is going to get us the angle between, basically, or the vector between both of these positions, and we can actually pass this in, so we'll have a direction vector coming through. And now on our bullet we can actually say rotation equals direction dot angle, and because we've set our rotation to 90, we actually want this to be a plus equals, so that we are, whatever rotation we're setting it to, it's additive to what's already there. And now, if I run this, we should see that our bullets are facing the correct direction. They've also picked up quite a bit of velocity through that change, which is unintended, but I think it's just because we're getting this direction here, and then we're not normalizing it. So if I do this, we should be good to go. Oh yeah, there we go. And look at that. That looks so good. It's a lot better. Even the small things, it just adds another kind of touch of quality to what we want to do. So this is great. I think we've got the rotation part good to go. And now the thing I want to focus on is to come back to what we talked about before real quick and talk about class names in Godot. So we're going to probably do some of this refactoring plenty of times throughout the way, but what I want to focus on now is what we were seeing just a little bit ago in our bullet manager, where we were saying, man, wouldn't it be nice if we had good type completion for our bullet class here? And Godot actually provides a way to do that. So you'll notice that if I have a certain type of node, for example, that's built in, Godot will be able to tell you the specific functions for that node that don't exist on other ones. And we can actually give it the same kind of knowledge about nodes that we create, like our own scripts. And so the way you can do that is by giving a certain script that you've created a class name. And so I can come into our bullet here and say class name bullet, and now I can reference the bullet type anywhere else within our code. So what I can do is come over here to our bullet manager and actually type this as a bullet. You'll see it picks up on it. And now remember, before I didn't get that auto completion on set direction. Well, if I get rid of this and start typing set direction, you'll see it's there, which is awesome. And then I just pass in direction here. Don't want to forget that. So this is a really nice way that you can, if you have a type or a script that you're passing around in a lot of places and using it wherever, this is a really nice way to give good auto completion to help Godot figure out what you're trying to do. So I believe that that's all I want to do with this right now. We can come back and do more refactoring, with that as we go. I will add a vector2 type to both of these. Personally, it's my preference to give types whenever possible. I think it just makes an easier developer experience, and it's easier for me to remember later on what to do. You absolutely don't have to do it. For a long time, dynamic languages like Python, which is what GDScript is based off, either didn't support or didn't encourage static typing. I come from not a object oriented, but even with something like TypeScript, which is kind of a static type system built on top of a dynamically typed language, is where a lot of my background is. And so I just have a preference for it. I think it scales better, but you do what is best for you. So the last thing I want to focus on today in this video, before we have a killer firing and bullet spawning system, is to actually add a bullet timer, basically, or a kill timer. Right now, if I fire a bullet, it's just going to go on forever. It's never going to end. I won't show you the actual scene tree with all the bullets right now, but take my word for it. It's never going to go away. And so what we want to do now is just add a timer to our bullets. So after, a couple seconds, they will go away. And so I'll come into our bullet scene here. I'll add a timer, and I'll just say kill timer. Whoops. And what I'm going to do is connect our timeout signal from our timer and then do some handling on it there. And previously in our main class, we connected a signal by code. So there's two ways to connect a signal. You can either do exactly what we did here by calling the connect method, or you can actually do it through the UI. And there's different different reasons you'd want to do one or the other. If you're dynamically creating instances of a scene, like you're creating it through code, you also have to connect signals through code. So if that's what your use case, then you've got to do it this way. But it is nice for every single bullet we ever make is going to have this timer. So it's kind of nice to do it through the UI. And the way you do that is you select the kill timer, come over here to the node tab, make sure you're on the signals tab, and then just double click timeout, and it'll autofill a method name for you, and you can select which node in your current scene that you want it to be connected to. Right now we only have a script on our bullet scene, and that's the one we want to connect to anyway. So I just hit connect, and you'll see it'll auto populate a method with the same name we saw up above. And all we want to do here is say queue free. And what queue free does is it's basically the Unity equivalent of destroy. It just tells the engine, hey, this object, whatever this script is attached to, the next time it's safe to do so, you can free it. So there is just a free method without the queue in front. You really don't want to call that ever. Queue free tells Godot to free it when it's safe to do so, whereas free is just an instantaneous freeing of that memory. So just always call queue free when you want to get rid of something. And a lot of people will talk, especially for something like a bullet where you're going to have potentially hundreds or thousands of them on scene at the same time, that you can use something like object pooling to make sure you're never actually destroying or freeing your bullets. You're just making them invisible, basically. That's definitely something we might get to later on. I doubt it in this series. We're never going to have enough bullets. I don't think that it's going to matter. But just as a heads up, that might change. If that's something you want to implement, you would do something different here rather than queuing it free. You might set it to be invisible or just return back to the pool. But anyway, so what's going to happen here is whenever our timer times out, basically it's done, this signal is going to get called, which will cause this method to go. And we can adjust how long that takes here. I don't think I want it as 1 second. Actually, we'll start with 0.5 just to make sure it works. A one-shot timer basically means once it runs, it doesn't automatically restart. And auto start means it starts right at the beginning. I'm not sure if auto start works correctly. I've always had issues with it. I just always manually start timers anyway, just to be clear. But I will set it to be a one-shot. And basically what we want to do is start our timer as soon as our bullet is ready. So as soon as it enters the scene tree and starts moving, we want to set that timer to go. So the first thing I'm going to do is add a reference. So let's say kill timer. Oops, I forgot the var. Kill timer equals kill timer. There we go. Sweet. And what we'll do is say kill timer dot start, and that'll start it. So whenever our bullet enters the scene, we'll start our timer, and whenever our timer is done, we'll queue free. And I think our bullet is moving slow enough that we should actually see this happen. So we should see our bullet disappear. There we go. So it's getting freed after a half second. I want to bump this up to be 2 seconds. I think that's a good time. Hopefully it should be off screen or right about. So, okay, we might not actually be able to see it, but I think this is great. This is kind of exactly the time I was going for, where it would be just off screen. So, basically whenever it left the screen, it would free the memory. So anyway, guys, I think that's pretty much it for this video. I hope you've enjoyed. Absolutely let me know any suggestions or feedback or things you want to cover next in the comments below, and I'll see you in the next video.